Hi, I'm Guang, I'm 15 years old. In this lesson on the techniques and applications of definite integration, we'll take a look at an example that looks like this. A double integration with the integrand of 2x squared y plus 9y cubed and dx dy. But your bounded area is bounded by y is equal to 2 over 3x and y is equal to 2 square root x. So, for this example, you would probably want to draw out your area first, right? So, drawing out your area. Now, if you realized y is equal to 2 square root x, that part is actually only in your first quadrant. So, you have something like this. Now, y is equal to 2 over 3x, that will just be a straight line. Y is equal to 2 square root x, that would be a curve. Whoops. That looks something like this, alright? So your area would be this part over here. So here is y is equal to 2 square root x, and this is y is equal to 2 over 3x. Right, so now that we know this is the kind of graph you're going to see, how about we take a look at what kind of boundaries it will have. Alright, so let's say we want to integrate with respect to y first, which will be from this straight line to the curve. But then you definitely have to know, well, is this along your x-axis, right? So then you will just equate the two functions that you have. So 2 over 3x is equal to 2 square root x. And you're just going to have square root x is equal to 3. So x is equal to 9. So this point over here is 9. Well, of course, if you want to have like other methods, you would probably want to know that this is the point 96, since you can just substitute in the value of 9. Right, so now that we know this information, we can start integrating it. So you will have double integration, or you can also change it to iterated if you're confident enough. Now, 2x squared y plus 9y cubed dx dy, or dy dx. It depends on whatever you like to use. So if you want to go with y first, then you would probably want to change this into a dy dx. So y, where is it from and where is it to? As I said just now, it will be from the straight line to the curve. Straight line is 2 over 3x, and the curve is 2 square root x. Now, your x range, which is from 0 to 9. Right, and this is what we are going to see. Now, of course, we will just integrate it. So integrate from 0 to 9, x squared y squared plus 9 over 4 y to the power of 4. Substituting the values, y is equal to 2 over 3x and y is equal to 2 square root x. Then dx. Right, so now we're going to put in the values. Integrate from 0 to 9, y squared, well, y is equal to 2 square root x. That will be y squared is equal to 4x, which is 4x cubed. And then you have to minus 4 over 9x to the power of 4. Then add on. So y to the power of 4, that means you'll have 16x squared, right? So 36x squared. And then minus 4 over 9x to the power of 4. Alright, So this is what you will be seeing. And of course, you can combine these two, make it look a bit simpler whatsoever. So you can also take out the 4, integrate from 0 to 9, and you can have minus 2 over 9x to the power of 4 plus x cubed plus 9x squared dx. Right, so all we have to do now is to integrate this part. So that will be 4, and you'll have negative 2 over 45 x to the power of 5, integrate from 0 to 9, then plus 1 over 4 x to the power of 4, integrate from 0 to 9, then plus 3x cubed, integrate from 0 to 9. Right, so this is what we are going to have to solve. Well, of course, stuff like 9 to the power of 5 might be a little too complicated for whatever we have right now to solve. So, of course, again, you can choose to use a calculator in order to solve whatever you have, alright? So what will be this answer that you have? Now, if you input everything correctly, that will be 4,811.4. Alright, so this is the answer that you should be seeing. Right, so this example over here, of course, you would start from whatever kind of graph you have, and with this graph, you would have to essentially determine where is it from, where is it to. Well, in this case, if you want to integrate with respect to y first, that will be from your straight line upwards into your curve. So after we know that, of course we have to know, well, it's the x. Since now we know the y, that was the x. And of course x, you have to find your point of intersection. So after you find the point of intersection by equating the two functions together, you would be able to change into iterator integration and then integrate whatever you have. And of course, do a little more integration to get your final answer of 4,811.4. But this question, it is not really the only method to integrate with respect to y first, since you can also integrate with respect to x first. Well, you just have to change whatever functions you see. And of course, you have to be aware of the kind of function that you're going to have, alright? So then you also have to be aware that when you want to integrate with respect to x first, you will have from 0 to 6. Alright, so how about we would just meanwhile take a look at how to integrate with respect to x first. Alright, so if you want to integrate this with respect to x first, you're going to see integrate, so that means you have to change your functions a little bit. Well, you start from the curve into the line. So the curve, although it is y is equal to 2 square root x, this time will be x is equal to 1 over 4y squared. And then all the way to 3 over 2. Let me just write this a little more separate. So x is equal to 3 over 2y. Alright, so then you have all these things inside, dx, dy, and then of course your range for y, which is 0 to 6. Now, when we integrate this, integrate from 0 to 6, then you're going to have 2 over 3 x cubed y plus 9 over, wait, this is not 9 over 4, this is just 9. 9xy cubed. Substituting the values, x is equal to 1 over 4y squared and x is equal to 3 over 2y. And then dy. Alright, So afterwards, then it will be pretty much simply just substitute in the two values that you have for each of them. So integrate from 0 to 6. Now x, you put it inside, you're going to have 9 over 4 y to the power of 4, then minus, so 1 over 96, and then y to the power of y squared cubed, which is y to the power of 7. And then you add on 27 over 2y to the power of 4, and you of course have to deduct something. So deduct 9 over 4y to the power of 5 and dy. Right, so this is what we're going to see. And of course, again, you could choose to put some of the things together. Integrate from 0 to 6. So the things that you can put together will be your y to the power of 4, where you're going to see over 4, so 9 plus 54, which is 63. Y to the power of 4, then minus 9 over 4 y to the power of 5. Of course, you can also choose to take out all of the 1 over 4s, but well, that'll be up to you. Minus 1 over 96 y to the power of 7, then dy. Alright, so now it's just to simply integrate it, where you will see 63 over 20 y to the power of 5, substitute in 0 and 6, minus 3 over 8 y to the power of 6, substitute in from 0 to 6, and minus 1 over 96 times 8 y to the power of 8, substituting the values from 0 to 6. And once again, if you could, you can choose to use a calculator in order to solve this part. So when you input everything, you will get your answer of, well, basically the same thing as before, which is 4,811.4. Alright, so this is what you're going to see. Now, I hope for this lesson you'll cover everything so far. Well, of course, what we did essentially was take a look at the graph and then use two different ways to solve one example here. Alright, so essentially what we see is here is method 1, and below here is method 2. Alright, so that will be pretty much all we have for this lesson, and I hope that you're clear of them so far. Alright, so I'll be ending this lesson here, and thank you for your watching.